this example, we will compute the critical value of a hypothesis test. Let's assume that we read in the newspaper that the average monthly rent for a student room in Delft is 450 euros, but we expect that it's actually more, so we want to perform a hypothesis test. Let's also assume that X, where X is the monthly rent for a student room in Delft, that's the variable we're looking at, that X has a normal distribution with mean mu and variance sigma squared. Now let's also assume that we already know what sigma is, that sigma is 120 euros, so that's our standard deviation. In this example, the null hypothesis is that mu is 450 euros. But we expect that it's actually more, so that's our alternative hypothesis. H1 mu is more than 450 euros. Okay, to perform a hypothesis test, we also need a test statistics. And in this case, our test statistic T will be the average monthly rent for a sample of 100 student rooms. And so we contact 100 student rooms, ask what the monthly rent is, and then take the average of that sample. Okay, here we take the average in a sample of 100. Since each of the variables has a normal distribution, we know that T has also a normal distribution. Normal distribution would mean mu, and variance sigma squared over n, where n is in this case 100. The significance level that we will use in this example, our alpha, will be 0.01, so 1%. Okay, so now the question is, what is the critical value of this hypothesis test? If you take the average month of the average rent of these 100 student rooms, what should the value be such that we reject the null hypothesis? Well, when do we reject the null hypothesis? We will reject the null hypothesis if the value of our test statistic is more than our critical value, and this critical value we're still trying to find. If this probability is equal to or less than 0.01. Now we can use that to compute C. Let's first make everything standard normal. So we'll take this T minus mu, in this case 450, because we will assume that the null hypothesis is actually true. Divide everything by our standard deviation, and in this case, the variance is, well, sigma squared over 100. Sigma was 120, so that means that the standard deviation is in this case 120 over 10. Where 10 is, of course, the root of 100. Now this new variable here has a standard normal distribution, so let's call it Z. So that means that we get the probability that Z is more than this value C minus 450 over 120 over 10. This probability has to be equal to 0.01. So what is the Z value for which this is the case? Well, we can look that up in our standard normal table. The probability that we're looking for is a probability 0.01, and we need to find the corresponding Z value. Let's take a look at our standard normal table. So remember that the numbers that you see right here are in fact the decimal numbers of the various probabilities. Well, in this case, our alpha was 0.01. So in our table, we're looking for 0.100. Now, if you look very closely, you see that this exact value is not in the table, but well, the value that we can find that is closest is this 0099. So the value 0100 is not exactly in it, but this one is the closest to it. Well, what is the corresponding Z value? Apparently 2.33. So the Z value that we need to use is 2.33. Well, and that means that we're almost done, because now we know that this value over here should be 2.33, and we can use that to compute the critical value C. We get this very simple equation that we can use to compute C, and if we would solve this entire equation, then we would find that C is equal to 477.96. And so if this average monthly rent for these 100 rooms is at least, let's say, 487, then we reject the null hypothesis.